Okay, so today we're going to continue on with the atomic structure. So yes, last lesson we did a bit of a basic introduction looking at protons, neutrons, electrons, isotopes, ions, that sort of thing. Now we're going to go a little bit deeper into that, but first have a go at the revision questions at the top of page 27. There's 6 questions there. Have a go at those. If you've So pause the video if you haven't done them. If you have done them, let's go to the answers. So firstly, atoms contain protons, neutrons, and electrons. The atomic number is equal to the number of protons. The atomic mass is equal to the number of protons plus neutrons. Neutral elements have the same number of protons and neutrons. Isotopes are the same element with a different number of neutrons. And an ion is an element that has gained or lost an electron, or more than one as well. So lose one or multiple, gain one or multiple. So let's have a look at today's stuff. We're going to start with um, the Bohr model of the atom. So we've basically just discussed the basic structure with protons, neutrons in the nucleus and the electrons orbiting around it. The electrons, however, they don't orbit randomly. Okay, they orbit in set paths in you know, at very specific distances from the nucleus, and we call these discrete orbits. So let's have a look at the Bohr model of the atom. So Niels Bohr proposed an early model of the atom as a central nucleus containing the protons and the neutrons being orbited by electrons in shells, or what we call energy levels. Okay? So each of these circular shells exists at a specific distance from the nucleus of the atom, and the electrons fill the shell starting from the one closest to the nucleus moving outwards. Okay? So each shell builds and builds as we go up with the number of electrons. Now, the first shell, each shell can hold a maximum number of electrons. The first shell, which we call 1n, that can hold 2 electrons. The second shell, 2n, can hold 8. The third shell, 3n, can also hold 8. Um, Now, as we go up through that, they do get a bit more complex. Okay. Um, so once we fill the 3 shells, okay, we go into the fourth shell and that fills up, but then the third shell gets a few more. So it goes 2, 8, 18, 8. The fifth shell does the same sort of thing, so we can fill the fifth shell up to another 8, and then the fourth shell goes up to 18. And then in the sixth period, we get sixth shell gets 8, and then the third shell goes, the fourth shell goes up to 32, and the fifth shell goes up to 18. Okay, so it is a bit complex. So for the Bohr model, you're just going to really want to remember those 3. Okay, you don't have to remember the last 4 periods, but those ones, like we will understand how it works when we look at the Schrodinger model of the atom in the next lesson. Um, but yeah, so for this lesson, we mainly just have to remember those first 3 periods. That the first one fills up with 2 electrons. The second shell fills up with 8 electrons. Third shell fills with 8 electrons. Okay, so so this is an example of how they're filled. So uh, period 1, the first atom's hydrogen, so it's got 1 electron around it. Helium gets 2 in that first shell. Once we go down a period to the second period, we start filling the second shell, so that 2n shell. So lithium has 1. We keep filling them. Carbon would have 6 in the 2n shell. Fluorine has 7. Neon has 8. Once you get past neon, that's now full. So it moves on to the next one. So period 3 has, for sodium, the third shell, so 3n, has 1 electron. Moving across to silicon, it has 4. Chlorine has 7. Argon has 8. Okay, so it's got that 2, 8, 8. So Similar to that, I'd like you to draw the structures for beryllium, oxygen, and phosphorus. Okay, so just draw a little nucleus, and then in the shells, start filling them up. So we draw one shell, maximum of 2, and then the second shell has a maximum of 8, third shell has a maximum of 8. Okay, so just pause the video, have a go at that. If you're not too sure what you're supposed to be doing, have a look at the first answer, then pause the video. Okay, so the answers. So what we basically need to do, have a look on the periodic table, find out where our element is. So beryllium. So beryllium is 4th on the periodic table, so it should have 4 electrons. Okay, so we draw a nucleus in the middle. First shell, so the 1n shell has 2 electrons. That leaves us with 2. And so the second shell should also have 2. Okay, so we just fill the shells starting at the center, moving out. Oxygen. Oxygen has a atomic number of 8, so it should have 8 electrons. So we start filling from the center. So 2 go in the first shell, and then 6 in the second shell. So in that 2n shell. Then we move on to phosphorus. Phosphorus has how many? 15 electrons. So we start with 2 in the center, in the 1n shell. The second shell has 8, so we're up to 10. So there should be 5 left, which is 5 in the 3n shell. Okay. The next thing we're going to talk about is what we call valency. So the outermost shell of each atom is called the valence shell. Now, the valence shell determines what charge the atom gets when it ionizes, and also determines a lot of the chemistry that occurs when that element undergoes a reaction. So the general rule we call the octet rule. So you'll need to remember this rule because we use it a fair bit throughout Module 1. And the basic rule is that atoms prefer to have their outermost electron shell completely filled. Now we call that the octet rule because if we go back and have a look at our, where is it? Yeah, our shell filling. So notice how there's 8, 8, 8, 8, 8, 8. So octet. So that's how the shells fill. So that's the basis of the octet rule. Okay, so everything likes to have that outer shell to be full, which is 8, usually 8 electrons. Now, for atoms that have 1, 2, or 3 electrons in their outermost shell, they prefer to lose electrons to fulfill the octet rule. I got a little star against number 2 because there is an exception to that rule, which is helium. Just because it's in the first period, it has to be difficult. It can only have 2 electrons in its outermost shell, and so then it's considered to be fulfilled for the octet rule. But the rest of them, every other period, so from period 2 onwards, atoms that have 1, 2, or 3 electrons in their outermost shell, they prefer to lose them. So, for example, here we've got sodium. A neutral sodium atom would have 1 electron in its outer shell, so it prefers to lose one. So that's why we get sodium plus. Okay, so you can see on the diagram there, it's lost an electron. It's got a full outer shell now of 8, and so it's fulfilled the octet rule. For atoms that have 5, 6, or 7 in their outermost shell, they prefer to gain electrons to fulfill the octet rule, just because it's easier than losing 5, 6, or 7. It's easier to gain 1, 2, or 3. So here we've got chlorine. Chlorine's got 7 in its outermost shell. Okay, but it wants to get to 8, so it's going to gain an electron. It's going to become Cl minus. So we can see now that it's gained that electron, it has that full outer shell. It's nice and stable. Now ones with 4 electrons. So 4 electrons have a bit of a choice. Okay, so if they've got 4 electrons in their outer shell, they can gain 4 to become 4 minus, or they can lose 4 to become 4 plus. So here we've got an example of silicon. So silicon's got 4 in that outer shell. It can either gain 4 electrons and go to the right, so it has 8 in its outer shell now, which is a full 3n shell, or it can lose 4 electrons and it now has a full outer shell, except the full outer shell is 2n. Okay, so they're both full, they both fulfill the octet rule. So yeah, that can go either way. So having a look at those trends, we're just kind of going to have a look at the periodic table. We're just going to ignore transition metals, lanthanides, and actinides because they're a bit more difficult. So we're just going to have a look at these groups here. So we've got group 1, 2, and group 13 to 18. So these ones, if we continue on, this is the charges that we should expect for each of these. So each of the atoms in group 1 have 1 electron in their outer shell. So we're going to expect them to lose an electron and become a +1 charge. Everything in the second group, so in that pink group, so from beryllium down to radium, they've got 2 electrons in their outer shell, so we'd expect them to lose 2 electrons to fulfill that octet rule. The third group, boron down to nihonium, they're expected to lose 3. The carbon group, they're the ones that can go either way, so they can go +4 or -4. Then the nitrogen ones are all going to be -3. Oxygen is going to be -2. The halogens are -1. And all the noble gases, they already have full outer shells. And this is why they're non-reactive, because they don't need to react now. They don't need to gain electrons. They don't need to lose electrons. They've fulfilled the octet rule. They're already happy as they are. Okay. So what I'd like you to do is, on this next page, I'm going to get you to predict some charges. So you're just going to use this table here to predict the charges. So the charges are the elements that I want you to do are magnesium, phosphorus, chlorine, potassium, strontium, and germanium. So I'll put back that table. Okay, so just have a look at that table, find where they are, and predict the charge on those 6 elements. Okay, so pause the video now, have a go at that. It's on page 29 of your booklet, and we'll get back to it in a sec. Okay, so let's have a look at the answers to that. So firstly, magnesium. Magnesium is right here. It's going to be a +2 charge. Okay. Next we have phosphorus. It's over here. That's going to be a -3 charge. Chlorine, just a couple over from phosphorus, which is going to be -1 charge. Potassium is over here in the first group, so it's going to be +1. Strontium is just down and to the right of potassium, so it's also going to be a +2. And lastly, germanium. So germanium is over here. It's in this fourth group. So it can be + or -4. Okay. So make sure you got those answers down. And we'll move on to our summary. So summary for today. Electrons exist in shells within atoms. The outermost shell of each atom is called the valence shell. The valence shell determines what charge the atom will get when it ionizes. Atoms with 1, 2, or 3 valence electrons prefer to lose them, whereas atoms with 5, 6, or 7 prefer to gain electrons when they ionize. And atoms with 4 valence electrons can either gain or lose 4 electrons to fulfill that octet rule. Okay, so that's it for today. So please move on to the questions on page 30, and that's all. Thank you.